Yes, I'm talking about reinforcement learning in Minecraft. I play lots of Minecraft, too much I think, and therefore I try to do sometimes some serious stuff with Minecraft, if you can say it's serious stuff. So like visualization of IoT data I did with Minecraft, and some other thing was connecting microservices for a shopping platform and building up a shop inside of Minecraft. And then I found the project Malmo, and yeah, with machine learning and everything, and there was some part with reinforcement learning. I thought, okay, I do now something serious again with Minecraft. And therefore I came up with this talk here. So, what problem do we want to solve? When you see this picture here, by the way, who never played Minecraft? Wow, so many. Normally I would say, okay, it doesn't matter, I took all the time for it, but in this case, who played Minecraft on the other side? Okay, yeah, more people didn't play it, okay. But doesn't matter, if you see this scenario here, you don't have to play Minecraft before for this talk, so you can stay here. Yeah, what do we want to solve here? There's a blue field, so what's this blue field about? There's this yellow-red thing. I think even if you didn't play Minecraft, you will realize that's maybe not a good place to walk. So this is lava, and when you fall into lava, you get the message, player try to swim in lava, and you die. So it's not a good thing. And then we have here also two parts like, more brown stuff. What's this about? And let's expect some robot or something which doesn't know anything. It doesn't see something. It's just be there and have to solve something. And that's what I want to do with Minecraft, Project Malmo, and reinforcement learning. Okay, so what's Minecraft? Minecraft was invented by Marcus Persson, also called Notch. He founded the company Mojang, and 4 years ago he came up with the idea, I don't want to do anything anymore, and tweeted, who wants to buy my company? Microsoft came up and paid $2.7 billion for the company. The reason, it's a best-selling PC game all over time, and Notch, the first thing he did was buying a house in Beverly Hills and rebuild it in Minecraft. So there's some YouTube videos where you can look how he's living now. And there are also rumors here, I think JC want to buy this house, but yeah, he has more money at this time. Okay, it's a three-dimensional environment, so everything, you have these blocks. Creative and building aspects, that's also something when you have kids and they play Minecraft, they're doing something creative. So on this way, it's a little bit hard to tell them, maybe you should go outside or play with Lego, which also are blocks, but Lego hurt when you step on it, Minecraft not so fast, so hard. And it's a sandbox construction game. So it's not like you're playing in like a sandbox, it's more like you have no rules what you are doing. So it's not like you have to solve this problem or that problem. It's more like you explore the world. Yeah, resource gatherings, like you chop down a tree and build out of this axe, and then you build another block, and then you build house, and crafting part is this. And also one thing is the combat thing. So maybe you heard about Creeper. This is a Creeper here. Kids are talking about this, and you have, what? Okay, Creepers, yeah. So they explode. There are also skeletons and zombies. But this doesn't solve our problem from the beginning. It's just about Minecraft. One thing which could solve this is the Project Malmo. It's from Microsoft Research Lab from London. They came up with the idea to build this platform for it. It's open source on GitHub. It's also Microsoft now. So I'm not from Microsoft, by the way, so I don't want to sell something. Even there's not only Microsoft parts on it. And it's based on Minecraft. And they're using Minecraft Forge for this. Minecraft Forge is a modding framework. Modding stands for modification. And what they are doing is they download the jar file. So Minecraft is written in Java. They download the jar file, disassemble everything, and then add some code, patch the code to put in some hooks. And therefore you can change the way it looks something. You can change the behavior on Minecraft itself. So normally you have, for example, you have a chest box which can be opened, but with the modding framework you can say only the owner of this box can open this and everything. And Project Malmo is using this for the world state to know, okay, where's the player, what's the situation, is he alive, not alive, also the area around and the images. So you get also some images back. Another thing is you can send commands like jumping, walking forward, backward, left, right. And everything is written in a mission XML file, so you can set up easily some scenario where you have define some blocks where the player starts and this everything. And you have also different kind of agents. So Python, sure, we're talking about machine learning. Python, I think, is more or less the standard for this. There's also Lua. The reason for this is the Torch framework, which they're using also. So when Torch is written in Lua, they're not using PyTorch. C++ is the reason. The modding framework itself is written in C++, and there are wrappers around for all the languages itself, also for Java. And yeah, C#, it's Microsoft. And then there's the arcade learning environment. Maybe you heard about OpenGym. This going this direction where you have some Atari games and also can do some machine learning with this one. There's some part implemented into this, so that's, Project Malmo. And there's a description about it, what it's supporting, computer vision and so on, but also the reinforcement learning. I thought, okay, what's reinforcement learning? So first of all, we have supervised learning. I think you heard already today something about supervised learning. This is where you have the classification. You have your dog, your cat, you train it, and what happens if you put a panda bear in front of it? Will it be a dog or cat? This is, image recognition, supervised learning. The other thing is the unsupervised learning, where you have unstructured data, where you have some table with data, and then you find some correlation between one kind of data and the other kind, and therefore, you train your system. This is used for maybe also prediction for maintenance prediction or something like this, where you don't know why the machine will get destroyed and find better thing. And also reinforcement learning, third part of this. And everything together, so the middle is AI. That's where everything flows into one. Reinforcement learning, you have an agent. In this kind, it's some Minecraft agent, but this could be some robot, something else. Then you have an environment, a world, a room, some scenario. And the agent sends some action to this environment, like moving forward, moving backward, and gets a reward for this. So maybe you just for moving one step you will get -1 because you moved. Other thing, you die into lava, -100. I get into this later. And the environment itself gives back also some observation. If the agent is alive, where is it on which position. And this is a loop. So agent moves further, and when it dies or when some failure is, then it restarts again, and it loops again, and tries to figure out a better way. And I like this quote from David Silver. He's from DeepMind, and if you look on YouTube, there are lots of videos about reinforcement learning. And yeah, it's a trial and error. So I don't know if you remember when you start walking, how you step by step fall down, stand up again. I couldn't do it, but I have some kids. Yeah, and then you realize, okay, that's the way, trial and error. Also like the example with driving a bicycle, this is more what I remember. So yeah, sitting on a bike, don't crash into a tree, and everything is fine. Stand up, go further. One exception is my brother. He was driving down a hill. In the middle was a fountain. He survived the fountain, and now he can drive the bicycle. Yeah, this wasn't like trial and error. It was just like driving. Also, one thing is this book. As you can see, it's from 1998. So it's nothing which was invented last 2, 3, 4 years. It's really old. The name is Reinforcement Learning. There are also some paper which is older, but it's one of the first books which get more into reinforcement learning. And inside of this book, there's a cliff walking example. And with the project Malmo, there are also some tutorials. Most of the tutorials are Python tutorials, and they use this cliff example. And this is also where the scenario from the beginning was. So yeah. For move, you get -1. If you find a blue block, you get 100. If you find a red or fall into lava, it's -100. So this is, yeah, 100 minus 100 for moving. Lava will be, no, -1 for moving, -100 for falling into lava. And I have an example for this. Okay. Let's see. Oh, it's still running. Cool. I'm using 3 steps. So in the first step, you have the code. I don't know if you can see it. But in the first step, it doesn't really learn something. It just takes the old value, which is nothing, and then it tries to find a way. So this is the first example. Let's do it this way. Back to game. And okay, it comes up, everything fine. I think everyone can, I couldn't move this. I leave it this way, yeah. And as you can see, here is the way it tries to learn. And it's just some random moves. So it starts, and as you can see, it's starting at the middle of a block where before on the side and in the back there's lava. So the chances to find the correct way will be very rare. It's getting a little bit further, but not really. So in the last number here is the reward or the value it gets on this state. So as you can see, it's always 0. That's the reason it doesn't learn something. It's totally stupid and tries to find the blue field or something. You don't know if you have to find a blue field randomly, which will not happen. Or I don't know. I never run it so long. So because this is not so interesting. So in the second step, it stores the reward. So it tries to learn with the reward. And only the reward. Do I have this one? Yeah, fine. Okay, and as you can see now, there are some red dots. And it's getting further, so it learns where the lava is. And especially in the beginning, don't jump into lava immediately. And now it tries to figure out what it has to do. And at this point, it's more or less finding the boundings of the lava. So, and as you can see, there's always -1. This is the reward it will get and stores this. And then it just compares between -1 or -101 for the lava stuff, and moves around. But it's not interesting. And I think when it falls into, so in this case the agent is called Christina, try to swim in lava. Which is funny at the first place, but if you fall into lava really with all your equipment, it's not funny. Okay, and step 3 is now using the Q-learning. I will get into this later, but first of all, an example. And it's also like in step 2, it takes the reward. I also find the way. But as you can see, there's, for example, -1.8. So it calculates something backwards. What you also will see is like at this block here, it has no idea that when it falls from down to up into lava, that it also on the same place can fall from left to right into lava. So it has totally no idea what it's doing. And now we have to wait to 37. And the way it's doing this is also finding the lowest value for the move. And from time to time with 10%, it's also just doing some random move. So this could happen. That's the reason it falls now into lava. Because it wants to try also some different ways, not to stuck on one way, more or less also try to be a little bit random. Yeah, and as you can see now, it found the blue block, and maybe you can see the green dots. I saw them so often, so for me they are visible. And now it learns the way back, so every time it gets a step further, this block here is getting more green. And now it shouldn't fall into lava really. Yeah, 36, 37 now it. Okay, 38. And as you can see, the reward is 90 at this. I think that's the best reward it will get, yeah. Okay. Yeah, it's fascinating. You can look at this. I have to stop now. I don't know how often I saw this already. Okay. So Q-learning. This is the matrix it found. And I thought, okay, when I talked to some people, do you see the green dots? No. And I thought, okay, maybe it's colorblind. No, because I saw it so often, for me, the green dots are totally visible. And I just played around with some filters, and this is the way. And as you can see, the upper one is more brighter than this dot here. So there's some value behind it. And this is the formula. And yeah, I'm not a mathematician, so when I see this formula, it's just like, wow, cool. There's an arrow inside of it. And the Q looks also so nice. Oh, and there are Greek symbols. Wow, cool. Yeah, I need code, and therefore just wrote this into code. And now it's, for me, it's more clear. So this is the new value. The Q is it's table, the Q value. S is the state, which the agent is standing at this time. A is the action it takes. In this case, it's just forward, backward, left, and right. Then it takes the old value. add some alpha value. I just choose 1.0, so this is the step size it will take to move forward. I have later on an example with different value, but it's the way it moves forward, yeah. If it's lower the value, it will be slower. The reason for this, if you maybe want to have some value which is better than the blue one, for example, gold block, which will get 1,000 as a reward, then with a smaller step size, it will maybe figure out this, golden block easier, because not moving faster forward. R is the reward itself, so I have it here. Then we have the gamma value. This is the discount rate. So this is like staying on one higher value, or if the value is lower, then we'll also try also different ways. So it's also to find a higher value instead of the 100. And then you subtract also the old value. Okay. And here this example when it finds the first time the blue block. So it's moving from this state to the left. Is it left? Yeah, it's left. And what will happen with this? So this is the formula itself. The old Q is 0. So I've never been at this block before, so the value is 0. Also the maximum of this blue field is 0, because I've never been there. The reward is 99, because I'm getting 100 for the blue field, plus or minus 1 because I moved there, so it will be 99. And now I just add in the values, alpha and gamma, and can get rid of all this stuff, and at the end I have 99. So this for the state moving to the left side will be 99. And then it starts again, and at one point it will be at this state. So it moves up to the other field. Same formula again. The old value was minus 1. So I've been there once before, and therefore I get this minus 1. The maximum value of this upper field is 99. Take this one. Reward is just minus 1 because I'm taking this move. Now I'm adding in the gamma value and this 99, and this will be 79.2. Add some other values, get rid of them, and at the end I have 78.2. So I have this value. And now I want to go back to the beginning to find my path to this blue field. And therefore I just dumped all the values out of the program. For better, to read it better, I replaced every minus 101 for the lava with an L. And as you can see, moving left, down, right, up, this is one block. So the 99 is moving to the left side to find the blue field. And this is 78.2. I just also get rid of only the higher values. And now it gets down to 61, 48, 73, and so on. And as you also can see, this value changed here, for example. So it always calculates also some values inside of it. 12, 8. And this is the path from the beginning to the blue field. And when the agent now starts, it knows, okay, on this side is lava. It's not a good idea to move there. So I'm moving on the right side, then up, left, and then it finds the path to the blue field. Clear? Think so. Hope so. Okay, and this is for alpha 1.0 and gamma 0.8. And now I've changed these values to 0.5, so the step size is slower. but the gamma value is higher. So the agent itself takes always the highest value. It don't try to figure out to get on the side for this, but it's slower. So this is after 40 moves. It still doesn't found really the beginning, so it's still -1 there. And after 60 moves, it's nearly found the way. And as you can see, it's only one clear path between. And there are some values, 47 or something like this. This is with the random move. It jumps on the side, calculates this, but sticks mostly of this path. So this is the way you can change with or play around with the alpha or gamma values. For example, as I told, yeah, if you have a golden block, which gets 1,000 reward to find this block. Okay. So now we know for this scenario, for this scene here, what's everything worth. So lava is not so good, blue is where we want to go, and the brown fields, this is the way we can walk. But what happens with a complete different scenario? So when I take now my trained model for this one, it will fall in the middle into the lava, because this was the path before. So this wouldn't work. It's only working for one scenario. And I think this is not the way we want to find our, maybe it's working for when you go out of the office, home. This is always the same way. You can learn this and do it and hope no road construction or something is between. You will find a way, but it's not how you want to learn your agent for this. And therefore, is deep reinforcement learning. And what's the difference between reinforcement learning and deep reinforcement learning? We are taking the supervised learning, so image recognition at this point. So it's a combination out of reinforcement learning and image recognition. And from DeepMind, they started with old Atari games. And this is the breakout game. They also have some paper for this. And let's take a look. So the only information they have is these images and also the points. And the points itself is just memory, somewhere in the memory when it counts up to 12 and the lives. So it's just some memory value. Yeah, now it finds the tunnel. So it learned by itself to hit the ball behind the wall. Yeah, you can also look at this many times. Okay, just going back. The way they are using the image itself, it's when you take a look at this image here. So you don't know if the ball is going up or down. Who's expecting the ball is going up? Down? No one. Okay. When you see it first time, it's going up. Oops. Yeah. So it's going up. What they are doing is taking two images, previous state, actual state, and subtract both images. And then you get a movement out of this. And I took this idea for this scenario here, and then subtract the image, and then it looks like some art. And therefore you can see the blue field, it's now more red and so on. So I took all the images from each walk, and also from lots of different scenarios. So I just changed the seed value, and then it regenerates the scenario differently. Looked at what was a good move, what was a bad move, and the images for this. And therefore I have 12 classes. So in this scenario, it's east, north, south, west, and to make it more complicated, it's upside down. So moving up is south. This one moving left is, it's upside down, and everything is wrong on this. So, for example, I have south super. This means it's moving up. Then I have also a bad move is falling into lava. A good move is just a good move, nothing really happened. And a super move is when it finds the blue block. And therefore I have 2 images for each move, and trained this with classification. So these are my classes for the classification. And here's the paper again from the Atari games. So they are using 84 by 84 image as an image size. They're using 2 layers, hidden layers. The first layer are 16 8 by 8 with a stride of 4. And the second is 32 4 by 4 with a stride of 2. 256 rectified units at the end. And the number of valid actions, in my case, it's 12. And this is the Keras code for this. So I didn't use TensorFlow for it because you have lots of lines and it's not readable, and for a conference it's easier to read Keras code. So as you can see, first convolutional layer are 16 8 by 8 with stride 4 by 4. As activation I'm using ReLU. Then we have the second hidden layer, the dense of 256. And here's the dense 12, so my 12 classes for south, west, east, north, bad, good, and super. And then I retrained lots of images and everything. And now I have a demo for this. How's the time? Yeah. Okay. Let's check if I have the correct one. Yeah. So I added a weight also inside of it, so you can see it a little bit better. And bad news, it doesn't work in this scenario. So now this is the same scene as before. It's standing next to the blue field, but it doesn't know that this is the blue field because I only have 2 images for the to recognize this move. And we'll never find it. It's always nearby. You can feel it. You can say, go! No. Okay, but I found some scenario where it's working. So 4338 as a seed value. It's this one. So it's a different scenario. Yeah, it's a little bit cheating because it's lying in the way. And now it found it. One more. It's also interesting, it moves left and right for some reason. Yeah. Oh, wait, I can. And here's the output. Okay. Where I am here. So this part here is the last move. So I'm adding also the difference between the two images in for the prediction. And this is the result. So these are all 0, 1, 0, 0. These are all my classification names. I think east is the first one, and so on. And then I just translated this in moving left is a good move. Moving up is super. So this is where the blue block is. And moving right is bad because there's lava. So in this case, it will use the trained model itself. And I can also demonstrate that's going fast. So just get rid of the sleeping. So it's working fast enough. And always find something. But not at my first scenario which I had, and I thought, why? Okay. Wait. No. Oh, I have sound. Cool. Now it's stopping. Okay. Okay. So takeaway for this is, Project Malmo. It's open source. You can download it. You don't need Minecraft. You don't have to buy the Minecraft game itself. So it's working without Minecraft. It's using Minecraft, but you don't have to pay for it. Reinforcement learning itself is something, I don't know, it feels it's new, but as you saw, it's really old. It's 20 years now. Most of the scenarios where reinforcement learning is used is for games. So this is also interesting. There are some research with robots. So you have really the agent stuff where you have some room or where it can move. Maybe also the way it balances itself. This is also done by reinforcement learning. We are doing it in a company a little bit, but I don't allow to talk about it, which makes it more fascinating, I know. Yeah, that's reinforcement learning. At one point it's get a little bit bored. That's the reason I also come up with the deep reinforcement learning, which opens up a really huge field because you have the image classification and try to find a way where the agent can find the blue block. So at the moment I just trained this data, and as you saw in the first way, it's standing next to it and doesn't find it. So at this point it's like maybe I have to do some calculation with 4 images. Other scenario would also be like using LSTM, different model for this, and so on. So there are also some frameworks where you can figure out which part of the image itself will influence the classification itself. So at the moment I don't know if it's a yellow stripe or orange stripe in the back which says, okay, was a good move, or is it really the blue block it will see? Also one problem is I have lots of data for good moves, some more data for the lava move, but only one at each run for a super move for the blue field. So this is also something where I'm missing maybe also some data for this. And it's totally fascinating to play around with this. Yeah. Okay. I will have some links in my talk also. So the book, the first version, 20 years old, they are writing on a second version for this book, which is online. Yeah, you can download it. I think it will stay online. And as I mentioned, there are the YouTube videos from David Silver. Yeah, he's at DeepMind and also was one of the guys with Google for AlphaGo and AlphaZero. Right, and the project itself. Yeah, it's funny to mention that it's on GitHub, which is part of Microsoft also, yeah. Yeah, thank you. And I'm around here, so someone told me if you put hi, Lars, on your slides, just come to me, say hi, Lars, and then we can get better in conversation. So this works from time to time, yeah. Yeah, that's it, thanks.